Hello. Uh, this is the first part of the HEC RAS learning course. So, in the first part, I will teach you some basics of the open channel hydraulics. So, in this open channel hydraulics, I will start with the basics. Okay. So here I will consider a river. Okay. So I will draw a stretch of the river. Okay, so this is the stretch of the river. So this is the plan view. Okay, so this is the plan view of the river. Okay, so if you consider the water is flowing from the point A to the point B, that is upstream to downstream. This is the upstream part and this is the downstream part. Let's assume if water is flowing from point A to B, what are the factors which affect the flow and the depth at the various point of this river channel, which affects the river hydraulics along the course of this river stretch. Okay, so if you consider along the stretch of the A and B, so one is the bed of the river between A and B. So this I will draw it here. So I will draw that bed of the river. Okay, so this is my bed of the river. Okay, between A and B. Okay, point A and B, A and B. So bed is at slope. Okay, it is having some slope, say 2% or 1%. Okay, slope in percentage I can say. Okay, and whatever the velocity of the flow which is passing through this channel will depends on the slope. Okay, the one is the slope, and another one is there are some boulders or stone, you can say. There are some boulders are there along the course of this channel reach. Okay, these are some boulders, and I will say at some locations there are some the grass weeds are there. Okay, the grass weeds and plants are there along the stretch of this stream between A and B. That's point A is upstream and point B is the downstream. Okay, so due to these stones, boulders, and this the weeds, so there will be obstruction to the flow of river. Okay, so there will be obstruction of the flow, so which results in the variation in the depth of the flow. Okay, and with respect to slope there will be change. If there will be change in the slope, then there will be also effect in the water depth at that location. Okay, so that I can say the velocity is a function of, one is the slope and another one is this bed material character, which can be hydraulically, which can be incorporated in the model as the Manning's roughness coefficient. So I can write it here. So velocity, I'll take some bigger text. I can say it's okay. Okay, so I can say velocity, that is V, is function of one is the slope, and the second one is the bed material character. So here you can see the bed materials are the stones and the agriculture stones and this plant weeds. So that means the bed material, I can say. So bed material which can be incorporated in the model as Manning's roughness coefficient parameter, Manning's roughness indicated by N. Okay, so based on this study, we then, as of now, we have studied about the longitudinal profile. Now we will consider the cross-sectional profile. So how it will the velocity or the hydraulic character varies with the cross section. So here I can say, if I take a cross section here, this is XX, and if I plot that here, this cross section XX, if I plot that here, so it will be like this. So this is the cross section, and okay, this is the water surface level there. Okay, this cross section also having the effect on the overall hydraulic behavior of the channel. Okay, if it is a wide rectangular channel, or you can say a case of the river where the depth is very small in comparison with the overall width. So here you can see, if I consider the wide rectangular channel or the wide channel, this is a typical case of the river where the width is very large and depth is very small. So this depth is very small in comparison with the width. Okay, so this will affect in the velocity of the water flowing through the channel. If the width is large in comparison with the depth, then possibility that velocity will be less. Velocity will be less if I will consider the same channel with the contracted section of the I'll consider same channel, but I'll contract the width of the channel. Okay, I can contract that here. So here I'll contract it. This is my contracted section. So here in this case the velocity would be more for the contracted section. Okay, so this is the overall introduction, and to summarize this, I can summarize the open channel characters, the factors affecting the open channel hydraulics into 3. So I'll draw that here in a new worksheet. Okay, so one is the shape. So one hydraulic character is the shape of the channel. Okay, shape of the channel. Second one is the bed material. Okay, and third one is the slope of the channel. Slope of the channel. Okay, the slope on which the river bed are laid. Okay, so these are the factors for the channel. I can draw the sections if it is rectangular, or sorry, I can draw with some neat sketch. Rectangular, triangle, or a trapezoidal. So based on the requirement, so this can be used in the design of the storm drainage gutters. So rectangular or this triangular or this trapezoidal. Okay, and regarding the bed material, so bed material, it can be smooth surface, I mean to say the smooth concrete surface, or you can say consider example of the smooth concrete channel, or